Okay. So I'm going to be showing the MVP for an application I developed called Discussit. I'll be talking a little bit about natural language processing and artificial intelligence, which is what I use to build it. But before that, it's story time. And first, I want to say, if you have been coming to these things, you have watched me grow up as an engineer. The first talk that I gave here, I was not employed as an engineer. I had never shipped anything. And in the last, I guess it's been 3 or 4 years, I've got 2 applications in production. I've got 3 in staging. I got and finished an engineering contract. I'm gainfully employed as an engineer, and I even got some sales. And a lot of that is thanks to the Elixir community and to Elixir Toronto for being supportive, for helping me learn, for giving me a platform, and acknowledging like what Mattia just did. So thank you. If you're a senior and you're engaged in the community, you're answering questions and you're helping people, you make a difference. You made a difference for me. And if you're a junior, keep doing your talks and aim to become one of these people, because you can make a difference too. So this was the plan. This is what I was going to do for this talk. I have this application that I wrote up. It's pretty freaking cool. It hooks into a phone system. It ingests all the messages and phone call recordings, transcribes them, and then it's using GPT to do summarization of them. It's pretty freaking sweet. So I've stood up all the procedural stuff. It actually works pretty well. And then I was going to go and I was going to learn the basics of the NLP and AI in this crappy live book script. And I was going to give a talk about it at ISTC, which is a technical writing meetup similar to this one. Then I was going to apply the basics of all that stuff that I learned, put it into my Discussit app, finish it this weekend, and come here and talk about it. Here's what happened. I got that done. I learned the basics on the crappy script. I talked about the crappy script, and then I made this post about it on LinkedIn. I was like, if you want this script, DM me. So this customer comes along, he's like, hey bro, I heard you got a script. I was like, yeah, I got it. You want it? He's like, yeah, I want it. And I said, all right, give me $5 for it, and I'll send you the script. And I sent him a Stripe invoice, and he paid it. He paid it. So as of Thursday, I have my first sale, $5. As of today, I have my second sale. Gross revenue is at $25.01. And the engineer in me said, after the hundreds of hours that I have spent writing software, I shipped 4 products. I get my first sale from a frickin' LinkedIn post for a script that doesn't even work. I got on a freaking call with this guy and tried to put the script and the live book on his computer. Totally bombed. 30 minutes later, we gave up because we just could not get it to work. So I spent the entire weekend standing up in an app in front of this stupid thing. And on the second implementation call, I landed in the Temple of because I friggin' tried to call this Python script to do some NLP stuff, soaked up all the memory, box crashed, still haven't got working software in front of my first customer. So what is this crappy script? So this is the entire application right here. Here's what it does. I got, in this example, I took a transcript from one of my favorite podcasts, Software Engineering Daily, because yes, I'm even a nerd in private. And it pulls in, actually, I have some slides for this. So what it does is it reads in this transcript, and it just chunks it really simply. On 2 hard returns, it'll string dot split back end, back end. Each one of those I consider a chunk. I convert it to an embedding. I stuff all those embeddings into, and I just use PG Vector for it, stuff all those embeddings in a database. Then I build this cosine similarity matrix that compares each embedding to each other embedding. And then I run it through a Python algorithm that groups all of those embeddings by similarity. Then I zip all that together, the content with the related embeddings, and then write a summary and a title for that cluster of content. And then you can slice into subtopics. So like if you get a pretty like dense topic at the top level, then you can slice in and you can get like, what are the topics that are contained in this topic? Then there's also a writing portion. So I basically take this nested thing of topics and I'm like, that's the outline. And then it will go through all of the topics. It'll take the topic, it'll convert it to embedding. It'll return all the content from the vector database that's related to that. Driving me up the walls. And then it will send the return context along with the outline heading into GPT-3 and say, generate me some text about this. And you wind up with a fully formed document about the topic that is well-researched, provided with the context from the vector database. And so like, I won't run too much of this because it takes, well, actually we'll just run one. So this little magnifying glass button here will basically, all it's doing is it's going to take all of the text inside that topic. It's going to convert it to embeddings. It's going to do the grouping, and then it's going to create these summaries of it. But if this was the outlining problem, is taking this transcript, grouping it by topic, and then drilling into individual topics if you want more detail about it. And then it'll turn around, oh, my document went away. We'll start that running in a minute and see if we can come back and see it. But I've also used this thing at work to produce documentation from like technical interviews and conversations that I have with people. And it has, I would say, like 80 to 90% accurate results. It's like going through this conversation, pulling out the right context, and then writing chunks of documentation about that topic. It's pretty cool. So here you go. This has come back with, 5 topics, 5 subtopics about this. And I'm now going to start writing the document as well. And we'll come back later and see if it actually finishes. Because like I said, this thing is held together with twist ties and Post-it notes at this point. So these are like, if you're going to go and do this, here are the things that I've learned. This is not, when you start going to learn NLP, vector embeddings, models, and AI, this is no longer procedural programming. This is a different ballgame. Like, you're going to take consistent output, you're going to have a consistent process to deal with that, or consistent input, you're going to have a consistent process to deal with that input. You're going to get an inconsistent output. You're not going to get the same thing every time. So if you're writing tests, as you should, you better get your mock game together. You better get your EX VCR game together, because this stuff takes a really long time to run. And if you want to write good tests, you need to make sure that you're able to get consistent returns for your tests. The other thing, this stuff soaks up huge amounts of compute and memory. And my example here, while I landed in the Temple of is that I was using Davenport to call Python, because there are just some stuff that's not super easy to do right now in Elixir because the library support just isn't there. So I was calling this Python script and it was blowing up and crashing the server. So you got to get ready for that. If you're deploying machine learning apps, they're probably, even at the lowest level, they're going to be more architecturally complex than just shipping a Phoenix app. Yeah, so like with that Python thing, I had to roll back my Davenport implementation, threw it behind a Lambda. Yeah, and I was up until like 1:30 in the morning fiddling with freaking Lambda timeouts. It's great. Also, if you're going to go down this road, you're probably going to go through some sort of pipeline. It's probably not going to be one call to some model to do something useful. And what you're going to find is, as you start making decisions about how do I chunk stuff, and how do I do the prompt, and how should I feed lots of text into the context window or a little bit of text? And there's so many knobs to fiddle with that if you get into the middle and you start fiddling with knobs, you're going to be in the middle forever. So screw it, move forward with whatever your first stab is and get to the end and then start fiddling with the stuff in the middle to get better outputs. So yeah, don't fiddle with the knobs in the middle. Wait till you get to the end. There's a lot of stuff to do in here. You may not like, and this was one for me, is text chunking. You wouldn't think that this is a big deal. But when you start getting in and you start dealing with a large text corpus or a large conversation corpus, and you need to start making decisions about how to chunk text together so that you get reasonable amounts of context to feed into the model for a prompt, there's a lot to this. There's a lot to it. The other one is vectors and embeddings. If you are not learning about this technology right now as a software engineer, you are missing out. There is some hugely powerful stuff in here, and they've made it pretty easy. It's something you can learn over a weekend. Go learn your embeddings. It's important. The other one is language interoperability, because here's my New Year's resolution is a lack of library support is no deterrent for me shipping my application in Elixir. If you don't have library support in Elixir, you should be able to figure out how to get that out of the language where it lives and then interoperate with that language to provide a solution. Then there's prompt engineering, which is a whole ridiculous thing. But if you want to write good applications using the GPT APIs, you got to know something about how to do it. And you really should learn these OpenAI. This is the other one. It's a really good way where in a weekend, you can get stuck into machine learning and generative models. It doesn't take that long. It's a really, really good thing to learn. These are the libraries that I really wish that I'd known about when I started. This first one is the one that gave me no amount of hell, because all I wanted to do was to count the tokens in some text to figure out how much context I could send the model. You would think this would be easy, but most of the options are like download this machine learning model and do some inference on your machine, or this massive Rust NIF that you have to include in your project. I don't want all that. I just wanted a little native Elixir library that would count tokens for me. And I bet I was looking for this thing for like 3 weeks before I found it. Highly recommend this GPT-3 tokenizer. PG Vector. You can go and do the Pinecone and the Milvus and the face and all that stuff. But if you're in the Elixir ecosystem, Postgres, because it's the only database. And PG Vector does the job. So don't bother with all that other stuff. Just get this PG Vector library in there. Like, learn how to use it. It's really, really useful. Python sentence disambiguation bound. I don't remember what it stands for, but it'll pick the sentences out. It's really nice. It's a good one. And it's not too memory intensive. So it kind of works to run that thing in production, whereas not so much with Network X. EXVCR. If you want to load this thing up in test and you're going to make 60 calls to OpenAI to get a reasonable data set so you can figure out if you're getting good results, you want to run that through EXVCR and match on the request body. It works really good. Earlport, not hard to pick up and not hard to find. And same with similarity. If you start working with vector embeddings, you're going to have to learn about this cosine similarity stuff. Check it out. This slide's from Tia. He's going to ask anyway. I'm deployed on fly.io. I had to pull out a custom. It's like I had to pull out a custom image and include PG Vector support on that image to make PG Vector work. I also had to mess around with my Docker file to get Python on there in the libraries. And then this topic analysis algorithm, I wound up having to put behind a Lambda because it did crash my server a whole bunch of times. So that's me. Hope you all enjoyed.
Thank you, Brian. Yeah, that was awesome as always. I'll start with a question. I would have asked about deployment, so good call. It is true. I always ask about deployment.
Now you got to think.
I wanted to ask you about the ports stuff. You mentioned that you use Airport.
Yeah.
What I used in the past was like the native Elixir port implementation. I wonder if, yeah.
I'm actually not super familiar with what's under the hood with Port, but I know that it has like out of the box support for Python calls, for example. So like I said, I don't know a lot of the details, but I think it's just spinning up a process and it's running Python inside of that process, or the port call is inside of this process. So you sort of start a process and then you do some Python stuff and then you stop the process. And then I think if you want to get, I found a nice article about this. There's a nice article about using Port and Poolboy and that may have actually solved some of my problems. But yeah, Port and Poolboy. So Google it. There's a really good article about it.
Cool. Thank you. Yeah, I mean, I felt all the stuff I've done in this field, I've held all those pains, including the out of memory stuff. So yeah, it's yeah, thank you for sharing that. Any questions from the audience here? Yes, Marco.
Great job. Yeah, it looks really cool. I just wanted to ask, generally, what did you find is not in Elixir? What did you have to reach to Python for more specifically?
So very specifically, it's called the Louvain community detection algorithm that basically you send the cosine similarity matrix to it and it will discover which of those items is related. So that's the specific library that I had to use because it didn't exist in Elixir. But there are a number of other things that would make my life easier if I would just give up and call Python. And one of the main ones is LangChain, because they put together a lot of like really nice tools for like map reducing prompts and stuff like that. So you can get a lot of convenience functions by calling out to LangChain. For my purposes, I've just handwritten it natively inside of Elixir because I'm obstinate and I don't want to call Python.